Perfect.
Hello? It's working, it's working.
Cool.
Announcement.
Announcement?
I'll just introduce you.
Uh,
Hi everyone, thank you for attending the 2002 Stats and Numerics Crash Course. Could we give a round of applause for Farhan?
Alright, what's up guys? I'm Farhan. While I'm going through this workshop, if I make any mistakes, just feel free to butt in and just call out while I'm talking, alright? It's all good. Okay. So what I'm going to be doing today, so I'm going to be going through the numerics past paper on Mobius. So there's this question over here, and there's also this question over here. And then afterwards, I'm going to go through some of the stat stuff from the 2022 term 2 paper. Get rid of that. Alright. These questions are kind of cooked. And then these last few ones I wasn't actually able to get completely. But I'll go through as much as I can, okay? Okay, let's get started with the numerics. So question 2, they've given us, this is from week 9 or week 10, the PDE's topic. So the temperature distribution T of xy is in a square heated plate of size L of 6 meters. This is working. It is working. Okay, cool. So they've given us an equation over here, a partial differential equation. So over here, call it a PDE, which stands for partial differential equation. If you guys done Math 2018, you guys might have seen a few of these earlier, but if not, don't worry, it's not too bad. And they've given us some boundary conditions over here. Boundary conditions, right? And these boundary conditions are mainly just the temperatures at the boundaries over here. So these are known and they're given to us. However, we don't know what these ones in the middle are. We're going to have to calculate those ones. Okay? So first question, what is the value of h, which is equal to delta x, which is equal to delta y? They've told us these ones are equal, these three subintervals, and they're each 6 meters in length. So we can just split up into 3 equal sizes, which is 2 meters each. Okay, pretty simple. It's question 1, easy. It might be different for you guys, because these are my questions that I got when I logged in. It might be a bit different for you guys. Alright? Hey, the coordinates of node 0, 0, which is over here, are given by x equal to 0 meters and y equal to 0 meters. Alright? And they've told us to find the coordinates of 2, 1 and 1, 2. Okay? 2, 1 is right over here. I'll do it in this. Can you guys see that? Yeah. Okay. So we're essentially just going to the right by 4 meters and up by 2 meters. If that makes sense. 2, 2. So that's 4 meters down here. And then we're going up by 2 meters. Right? So our x coordinate will be 4 meters. Y coordinate will be 2 meters. And if we're trying to find 1, 2 up here, yeah, we're going to the right by 2 meters and up by 4 meters. Okay? By the way, I'll be posting these up, I don't know, after the lesson. Okay? Okay. So far makes sense? All good? Pretty easy so far, right? It's not too much work. However, now we're taking a look at the boundary conditions. Right? So I've drawn up a small diagram over here. So when x is equal to 0, so they've given us this boundary condition over here. Whenever x is equal to 0, and this y value can be anything. It's just varying y value. Okay? That is when our temperature is equal to 0. So everything on this side will equal to 0 degrees. Make sense? Yeah. Now switching on to the next one. When x is equal to L, L they've given us to be 6 meters. So when x is equal to L, we're going all the way up until this point, right? And our y value can vary. It can be whatever you want. Yeah. It can be anything between here and any point on this line. Okay. So the temperature on that side is just 20 degrees. Cool. We can do similar things for up here and up here. So they've given us when y equals to 0, so that's the bottom boundary layer down here. They've given us that when it's equal to 0, our temperature is 40 degrees. Yeah? When we're taking out y equals to L, we're going 3 meters up. So we're taking a look at this boundary layer over here. Yeah? The x value can vary. Our temperature at that point is 100 degrees. Cool? So pretty much what they've told us to do is find the points and what's the temperature at those points. It's pretty simple for us that these ones are just lie on the boundary. There's nothing in between here. Okay? To find these, we'll find those later on. But to find all of these are pretty easy. Okay? So I'll quickly do a small diagram. So at this point, x equals to 0. So this is 0 degrees, 0 degrees, 0 degrees. We can also let this be equal to 0 degrees. A small problem that we face is that this side can be 0 degrees, and this side is, what did we say? 40 degrees, right? So this point has two temperatures, right? But from the lectures, Elena said that it doesn't really matter which one you choose. So it can be either 0 or 40 degrees. Yeah, you'll get the same answer anyways, okay? Same thing for all the corner boundaries. Yeah? You can just choose one and it'll be all good. Now up here, we get 100 degrees, 100 degrees, 100 degrees. On the right side, we get 20, 20, and down below we get 40 each. Okay? Okay, so T of 1, 0, which is here, we've already established that it's 40 degrees. So our answer is 40. 2, 3, which is over here, 100 degrees. So answer is 100 degrees. At 3, 1, which is over here, temperature is 20 degrees. So our answer is 20. And 0, 2, which lies up here, our answer will be 0 degrees. Okay? Cool? Okay. Okay. Now we're getting to like more of the actual partial differential stuff. At the moment, we're just taking a look at points. Yeah, not too difficult. Using our finite difference formulas for the first and second derivative, write the finite difference equation in general form. Okay? So these equations are the finite difference formulas that they've given us. Right? Let me try. Actually, let me go to Mobius real quick. Oh shit, what's that one? Now I'll show you guys where it is. Down here. Alright, these are the formulas they've given us. Okay? And all we have to do to find the general form is substitute these equations into this equation up here. Okay? So I've done this for you guys. So once you sub it in, 3 times our second partial diff. Sorry? Can you see? Yeah. Okay. Yeah, so pretty much we're substituting these in up here. Right? So after you sub it in, it's just a bunch of algebra. Okay? Not too bad. At the bottom over here, we get delta y and delta x, which is what we found in part A. Okay? So it's just 2 meters. So down here, I can just let this equal to 4, 4, 4, and 4. And after you substitute everything in, you get a pretty long equation over here. But there are some like terms. So we get this one and this one over here, like term. This one and this one. This one and this one. This one, so on. All right, you guys will get it. Yeah, after you do the algebra, you get your final answer to be this. So you just have to take a look at the coefficients, which over here it's 1, 5, 1. And that is all you have to place into here. Okay? Not too bad. Yeah? I multiply both sides by 4 to get rid of the 4 in the denominator, and you get 16x squared y on the right hand side. Yeah? Okay, cool. All right. Now, for part E, what they're asking us is just to sub in our node points, right? So for I and j, so our node points will come in this form, I and j, yeah? We're just gonna have to sub these values in. So for 1, 1, we're gonna sub it into here, down here, into the subscripts, okay? And we're also gonna need to sub it into here to find the xi and the yi values, okay? Okay, so for node 1, I'll go through, I've made solutions for node, the first part, second part, then these two over here, I'll go through with you guys down here, okay? So for node 1, 1, substituting into this equation up here, actually what I'll do, take a screenshot of this one. Oh, that's cool. Okay, never mind. We'll just use this equation over here, okay? When we're substituting our 1, 1 up here, we get t of 1, 1, t of 2, 1, t of 0, 1, t of 1, 2, t of 1, 0, and 16 x1 squared yi. Right? And what we have to do is find the coefficients of each of these ones and match them up. Okay? So for t1, 1, see where it is? It's over here. The coefficient is negative 12. Right? For 2, 1, which is over here, our coefficient is 5. For 1, 2, which is over here, our coefficient is also 5. For 2, 2, we can see that there's no 2, 2 for the node 2, 2, right? There's no temperature point that we can find at the moment. So we just let it be 0. Cool? Yeah. And then this 88, I'll quickly show you guys where it comes from. So x1 and y1, if we're taking a look at it, just scroll up a little. x1 is this up here, and y1 is this. Yeah? It's going up by 1 unit and to the right by 1 unit. Yeah, 1 unit, that's right. So that's 2 meters, 2 meters. Therefore, x1 is equal to y, x1 is equal to 2 meters, y1 is equal to 2 meters. Cool? Yeah. Okay, so I've substituted these values in. We get 16 times 2 squared, which is 4, times 2. Overall, you get 128. Right? But on the left-hand side, we also see that t of 1, 0 is one of the boundary conditions. Okay, t of 1, 0 lies over here, which is 40 degrees. Yeah. So we can just bring the 40 to the other side, and we get 88. Right. So for part, what is it? For the first part of part E, that is our answer. Okay. I've done something similar for 2, 1, for the node 2, 1. But we get 2 boundary conditions, right? And overall, this one becomes 5 times 20, which is 100. This is just 40. Taking it over to the other side, we get 512 minus 140, which is 372. Okay. And these are just the coefficients that you guys can just copy the same thing over here. Okay. So I'll quickly go through for node 1, 2 and for 2, 2. I'll do it right here. Okay. So for node 1, 2, okay, let me quickly pull out the equation. Let's drop it over here. Okay. So for node 1, 2, we get negative 12 t of 1, 2 plus 5 of t 2, 3, no, 2, 2 plus 1 of t 0, 2 plus 5t of 1, 3 plus 1 t of 1, 1. And then x of 1 is equal to what? 2, good. How about y of 2? 4, perfect. Okay, so substituting this into this small equation, we get 256. Okay. Now taking a look at the left-hand side, there's a few boundary conditions, one over here and one over here. Okay, so T02, T of 02 is right here, which is just 0. Okay, so we can say this is just equal to 0. T of 13, we also know what that is. It's 100. Cool. So we get this to be 100. So altogether, this term just becomes 500. 5 times 100, which is 500. Okay. Now, do we have any other boundary conditions? Nah. These are all the interior points. Okay, we've got no clue what they are. So writing a final equation. So we also want to find what T21 is. We don't know what that is, right? So we get minus 12T12 plus 5T22 plus T of 1 equal to 256 minus 500. And then actually now I also want to add a 0 of T22, was it? 21, which is equal to negative 244. Why are you laughing? Very good. Is that all good? Makes sense or no? Everyone good? Okay, that's good, that's good. Okay, no one's giving me a response. So that is our answer. Okay. How long do we have? Do you guys want to try node 2.2? And then I'll just put no, you don't want to try it? Okay, then I'll go through it then. Okay. Okay. I'm going to be using the same formula. Is it actually making sense, or should I go slow? Blah? You good? Yeah? Okay. So for node 2.2, minus 12T22 plus 5T32 plus T of 12 plus 5T of 23 plus T of 21, which is, what's x, sorry, x2 and y2? What's x2? 4? Good. What's y2? Perfect. Okay. So substituting these on the right hand side, we get 1024. Alright. And do we have any boundary conditions on this side? 3, 2 and 2, 3. Good. Anything else? No, good. So what's 3, 2? Let's scroll up a little. 3, 2 is 20 degrees. So scroll down a little. This will be 20, 100. Okay. Then the point 23, which is, where is it? Up here. It's 100. Okay. So this is 100. This whole term becomes 500. Okay. So writing our final answer, we get minus 12T22 plus T of 12, which is equal to 600, 124 minus 600, 424. Okay, now if we're taking a look at the coefficients, wait, hold on, let me quickly wrap these up. Okay, so for T22, which is over here, we know the coefficient is negative 12. How about for T11? What's the coefficient? 0. Good. T21? 1, and T12, 1. Okay, so we get 1 and 1. And we said this side is 424. Okay? I don't think you can do this on MATLAB, because like all of it is just algebra work.
How do you know which finite difference equations to use when it's not given? Because in the weekly quiz they said just use the appropriate ones. They said use the centered finite differences, the order OH squared. Do you know how to
No, I don't. No, I don't. I'm sorry. I'm just using this because they've given it to us, but I think I'd assume you'd use a centered one.
But there's different centered ones.
What do you mean?
Like there's multiple centered.
Is there? Oh, so you're talking about these ones over here?
Yeah. They said use like order OH, like OH squared.
This one over here. Okay, surely, like,
That's not partial, you know what I mean?
yeah, I get what you mean, yeah. No, I'm sure they would give it to us. Because, like, there's no way we would just have to assume something else. And if you get it wrong, they haven't taught it to us either, so, like, I don't know. Okay? Okay, can I move on to the next part, by the way? Making sense so far? Okay, cool. Alright, now this part you actually need MATLAB for. Okay? Yeah? So to solve the matrix, you're going to need MATLAB, or Maple, but we don't use Maple, right? So from these equations over here, we can actually form a matrix. Okay? We can form a matrix. So I'll quickly write up a matrix on MATLAB. Shut up. Okay, can you guys see that?
Yeah.
What happened? Bad. Why is it taking so long? Okay, so we want to find these internal points, a matrix for that, right? And so we can form a matrix using these coefficients, yeah? So I've put this over here. So we're trying to solve for AX equals to B. B is equal to the points that we found on the right-hand side. Okay. So, yeah, raise your hand next time, man. So AX, we're solving for X, right? We know what A is and what B is. A is just formed through the coefficients, right? So we're trying to solve for this T11, T21, T12, T22, which is equal to this. Okay, by the way, before I move on, does everyone see where I get this matrix from? Yeah? Okay, that's good. And then you just chuck it into Maple. MATLAB.
Is it always a symmetrical matrix? Like on the diagonal? Or is that just coincidence?
No, I actually didn't realize that. I don't know. Does everyone know how to put in a matrix into MATLAB? Yeah? Yeah, okay. I learned it like last night. Yeah, sure. Okay. So to put in the rows over here, we're just gonna separate it by a comma. Right? Why? Did you ask why?
No.
Oh, right. Okay. And then to separate the rows, you're gonna have to use a semicolon. Yeah. So I'll quickly show you what I do. I think this is right. 0. And then this for the next row.
Makes sense.
Okay. So then you get 1, -12, 0, 5. I want to make it look nice. Okay. 1, 0, -12, 5. Then 0, 1, 1, -12. Let me see if that works. Yeah, that's our matrix right there. Cool? No worries, man. And then B is equal to just a vector, which is 88, 372 minus 244, 424. Is that a vector?
Wouldn't there be like different rows?
Yeah, sorry, there should have been different rows, yeah. Oops. And then, is that better now? That's a vector, okay, cool. And then they've also given us the code for the MATLAB. So you can just be like, oh, x is equal to a, this dash, and then that, and then, why is it that dash?
Because that's how it is.
That's just how it is. That's literally just how it is.
That's cool.
Oh shit. Okay, another way you can do it, you can do this by the way. A to the minus 1 dot b.
Yeah, that's better. I like that.
You same answer, right? I prefer this way because I didn't know about the other one. So, wait, quickly before I explain. So the reason it's that is because you're taking the A inverse of both sides, matrix inverse of both sides. Then this becomes the identity matrix. So you just get x, b. Yeah. So that's how you get it. So that's our answer right there. Solve on MATLAB.
Can you quickly do A/B?
Yeah, sure. Like this one?
Yeah.
Doesn't work. The dimensions don't match, right? I think if it was a square matrix, that is a square matrix. No, I don't know. I'm not a MATLAB pro, so you're gonna have to ask someone else. You get minus 27.3. Okay. Those are our answers. Cool?
Yeah.
Okay. Is there anything that I need to go over again? Did I go too fast? Or no?
Thank you.
Yeah, all good. You guys at the back, good? Alright, good.
So is it, let's say we have all the T11s. Do they have to match vertically or horizontally?
Are you talking about the
Like, when you put-
coefficients?
Yeah.
Vertically.
Vertically.
Yeah. Because the reason for that is when you... Okay, I'll quickly show you why.
But that's how
So
they.
horizontally, you're just following the equation basically.
Yeah.
All the little people.
No, no, that's true. What he said. So if you guys remember from 1a or 1b, if you want to multiply this out, you're going to have to dot product this and this, right, to find an equation. Then next row will be this multiplied by this multiplied by this, and then this multiplied by that. Yeah, from 1a, 1b, 2018, whatever you've done. Okay. All right. Who else is doing 2002? You? Are you doing it? You guys as well? Okay, cool. Shit, we got a lot of people. Oh man. Alright, I'll move on to the next question. So I'll quickly show you guys the answers. Okay. These are the answers. Okay, next question.
So on the weekly, there's one extra question at the bottom. It's to
Yeah,
solve
there is, right? On the week 9 one?
Week 9, yeah. Do you know how to solve that?
I got 2.5. This one?
Yeah.
Yeah, nah.
You don't know?
I haven't tried it, so I actually don't know. It's required to calculate the heat flux at the two boundary nodes. What's the two boundary nodes? 3, 2.
Yeah.
3, 2, and 1, 0.
Maybe you would just sub in the finite difference in things.
Yeah. So they've said choose a suitable one. I'd assume you'd have to use the same ones from over here. So you use these ones. Alright. So let me quickly take a look. calculate the derivatives, enter. Oh, yeah, so I think what you'd have to do, so you're trying to find these ones, right?
Yeah.
So you'd sub in the nodes 3, 2, and then 1, 0 over here, and then you already know what your the temperature at those points are, right?
Yeah.
So you sub in your temperature at that point, and then your delta x, and then you get your value for.
And do the I minus 1, I plus 1.
Wait, let me quickly try it out then. So at 3, 2. Wait, I'm gonna quickly try this one, so you guys get it as well. Temperature at 3, 2. Is 60. Then at what was it? 1, 0. 1, 0. Down here. You would get what? 25, right? Everyone, oh shit. I mean, everyone see that? Yeah. Then we're trying to find that delta t on delta x. T of, I'm gonna use the formulas back here. T of I plus 1 j. T of I minus 1 j. 2 delta x. So for 3, 2, it would be T of 4. 4, 2 minus T of 2, 2. Does 4, 2 even exist? Bro, it doesn't even exist. Wait a second. Yeah, I'll do it for 1, 0.
I'm pretty sure you used the forward, backward, or centered.
Yeah, I think you can't use. Which one am I using right now?
So if you go to the formula sheet with the forward, backward, and centered equations,
Yeah.
and you find the one which has that sort of order OH squared.
This one. Yeah. Fuck. This one, right?
So yeah, because we don't have 4, 2.
Yeah, you can't do
You just
14.
want the backward different ones, yeah.
Yeah.
Order OH squared.
Yeah.
Decide what we do.
What I'll do, because it's taking too much time, I'll come back to it. Okay? I'll come back to it after I finish this question. I'll come back to it. Okay. A tapered cantilever beam of circular cross section and length 5 meters supports a concentrated load P equals 1 kilonewton at the free end. Over here. They've given us RA is 0.5 meters, RB is 0.2. And then they've also given us a formula for IX, which we can kind of simplify. Right? So once you substitute all your values, we get this term to be 0.06, this one to be 0.5. Right? And then substituting this into here, we get a formula for d squared y and dx squared. Cool? And using this e value as well. Cool. Have I lost anyone? You guys see it? Yeah? You don't see it? It's because you're fucking talking, bro. Alright, listen. So we're solving for d squared y over dx squared, right? We're trying to make it the subject. We know what e and ix is, right?
Yep.
So e is that thing, and then ix is that thing over there. Alright? So once you just make it the subject, take this to the bottom, down here, and then you get that formula eventually. Okay? I'll just simplify it down a little, but you get this. Okay? They've given us some initial conditions. Initial conditions. Cool. Yep. And then the first question they've asked us to find, they've introduced z equals to dy on dx. And now because z is equal to dy on dx, we can say that d squared y on dx squared is equal to dz on dx. True?
Yeah.
True, right? You're just differentiating both sides with respect to x. Okay. Okay, I've also kind of extended the table to make it a bit easier to see which what I actually stands for. It's just a interval, I guess. And then you get 0, 1, and 2. But the x values are a bit different, right? They've taught us the step. Oh, you can say this is the step number, right? The actual value for the step, though, is 0, L over 2. L over 2 is just 2.5. And then L is just 5. You good? Okay. Okay. I'll rub these out real quick. Okay. So apply Euler's method, which they've given us over here. Euler's method. So we can find, this concrete. We can find y0, so this is just y0, z0, using our initial conditions, okay? Which they've taught us up here. y0, and this is z0, right? Everyone see why that's?
Do you even need to look at the diagram?
No. I don't know. Just trying to throw you off, but it's not that deep, okay? So this is y0, z0, right? Therefore, we just get this to be 0, 0, okay? Then the derivative, what happened? Alright, if we're trying to find f1, right? What is f1? dy and dx, right? dy and dx, true? Right? What is dy and dx equal to, though? F1, yeah, that's true. It's equal to F1. What is equal to Z? It's equal to Z, right? So we're trying to find this at this step 0. But we already know what Z of 0 is, right? And because of that, we can just let this be 0. No! Sure, hold on. Let me get my charger. Let's charge it. Alright, beautiful. Okay. Shh. Hey, how about F2? What is F2? What's F2? You said? dz on dx, true. So this one over here. What is dz on dx equal to? dy squared on dx squared. Oh, sorry, d squared on dx squared. Okay? So we're trying to find the value of this at x0, y0, or z0. Right? So we just scroll up a little. All we need to do is sub 0 into this equation. That's literally it. Okay? So it's, this is equal to f2 of 0. Since f2, since it's not in terms of y, it's only in terms of x. It doesn't matter what the y and z values are, right? So scroll up a little, y and z. So we're trying to find out at the point x equals to 0. Right? When you sub that into your calculator, you get negative 0.0102. Yeah? So you just substitute in. Yeah? Luke, make sense?
Yeah.
Okay. Okay, I'm going to ask you guys to help me with these ones. If we're trying to find y of 1, how can we do it? And it is. Y of 1?
You sub it into Euler's?
Yeah, perfect. Just sub into Euler. Alright? So this is what I've done over here. So you just let the I equal to 0. Yeah, right. To find y1, okay? So y0 is what we found up here. You get 0. This one, straight from here. You guys see that? Yeah. So you get 0 as well. And h doesn't really matter because we're multiplying it by 0. Okay. So our y1, we just get it to be 0. 0. 0. Okay. How about z? What can we do for z? Not Jad, someone else. Yeah. Yeah, Euler's again. Perfect. Use Euler's again. So for z1, we get z0 plus. We know what this value is. This value is straight from here. So substitute it into here. Okay. And we know what h is. What's h?
2.5.
Yeah, sure. You guys already saw it. Okay. So it's 2.5, which is given over here. Right? So just chucking this into the calculator, you get your answer to be 0.0255. Okay. Although your numbers might be different, the steps are exactly the same. Okay. So you guys can try it with your own numbers. I don't know if it'll be the same numbers though, but yeah, the steps will be exactly the same. Okay. So this one we get 0.0255. Negative. Negative. Okay. Okay. How about F1? What did we determine earlier?
Z.
It's just Z, right? Okay. So, this one over here, which is equal to Z. So it should be the exact same answer. Okay, let me check that. Yeah, it is. Okay, I did double check. Okay. Is that clear, by the way? Or do I need to re-explain why it is? Clear? Yeah? Sure? Okay, sure. I'll move on then. F2. How do we find F2 again? Someone remind me? Subbing into? Which one? Yeah? You're correct. Yeah, you.
Just the set formula that you square y over here square one.
This one, right?
Yeah.
Yeah, perfect. So we're gonna instead of x, instead of it equal to 0, we're gonna let it equal to 2.5. Okay, we're gonna let it equal to 2.5. So after subbing x equals to 2.5, you get okay, you get d squared y over, I'll just say f2 is equal to after doing that in my head, I got 0.0212 negative 0.0212. Yeah. Cool. And then our last two things that we need to find out are the y. Oh, the last two we have to find out is this value and this value. Okay, we don't need to find these. They didn't ask us to find it. Okay. So how do we find this value again?
What do you mean they don't ask us to find it?
They didn't ask it in the thing.
Oh, in the
So it
actual-
didn't- yeah. So. Okay. So how do we find it? How do we find it again? Oh shit, I already found these by the way. Who said Euler? Yeah, good. You have to find Euler. You have to use Euler's formula, sorry. So you get y1, shit. y1 plus f of 1 x1 y1 z1 multiplied by h. Okay. So you get this to be, what's y1? 0 plus negative 0.0255 times 2.5, which is equal to, I'll do that in my head real quick. You get 0.0638. Negative 0.0638. Yep. Then for z, you get z1 plus f of 2 this time, x1, y1, z1 times h. Alright? So this one, after doing it in my head, I get 0 0.0785. Negative 0.0785. Yeah? Cool? Alright. You guys at the back, all good? Alright, that's good. Alright, so that pretty much gives us part A. Okay, but then there's also a part B to this question. Down here. Oh, shit, okay. So that's using Runge Cutter.
So
MATLAB, exactly. You can do Runge Cutter by hand. It's just going to take ages, okay? It's doable by hand, just takes a while. Especially because for this type of question, it's a system of ODEs type question, okay, if that makes sense. All right, so for Hyun's method, is that how you say it? Hyun's method?
Yeah.
Hyun's method, something, right? You're going to have to use these formulas, okay? The thing about Runge Cutter, it's actually pretty easy on MATLAB, okay? So I'll quickly show you guys the code.
Can you do it from scratch?
You want me to show you best from scratch?
No, like, can you do Runge Cutter by scratch? Like from scratch, not anything other than the equations?
Sorry? Without the equations?
No, it's fine.
No.
Write it out from scratch.
Like
Right.
during the exams, you need to write it up from scratch.
Oh yeah, it's very doable by scratch. So I'll just show you real quick. Okay, so the first thing you wanna initialize your values. So they've told us. Actually, we wanna identify which two equations we're using. Okay. Can you guys see? Okay. So we've given these two equations, right? So for the first derivative of y and the second derivative of y. Okay. So what I'm going to do, I'm going to say f1, which stands for the first derivative, at x, y, z. Yeah. The reason I'm saying x, y, z is because it's in terms of x, y, and z. Right. What would it be? What would the first derivative be in terms of x, y, z? Yes, z. Who said that? Yes, z. Alright, then f2 is equal to at x, y, z is equal to second derivative, which is what we know from here. Okay, so I'm going to quickly check that in. Yes. Okay. Let me quickly check if they're right though. Oh yeah, actually one thing. I don't think we need to put the dot here. I don't think it really matters. It doesn't show anyways. You can also use sims x, right? But what I tried to do sims x, then write out this one, then integrate for the second one, the first derivative, but it doesn't work. It gives you an exact value, which is not what they're looking for. We're trying to do an approximation, which is what numerical methods is all about, right? Okay, so now we're going to do the initial values that they've given us. What have they given us? They've told us that f1 of 0 is equal to 0. Oh, actually, no, what I'll do, I'll say that y of 0, 0. So what this does, this actually makes an array for y. What else is there? Z. What happened?
Oh, don't worry.
Oh, okay. I said, and this one makes one for z. Oh yeah, I did make a mistake earlier. I put it as 0, but then that's for Python. For MATLAB, the very first indices is always 1. In Python it's 0, but in this case it's 1. Okay. Okay. Now we're going to introduce the Runge Cutter equations. Okay. So I've got a few listed up here, and you also want to introduce one for x. So this one over here, I'll quickly show you what that looks like. The x one. Yeah. So that's exactly what we had over here. All right. That's just our x array. Okay. Or you can also write it as 0, 2.5, and 5. It's the same thing. Okay. And you will also get the same answer down here. Okay, so now to write our range cutout equation. So if I scroll down, so this is K11, K12, K21, and K22. So you can just straight up just copy these equations word for word, just type them out into here. Yeah, that's literally all it is. Cool. So these are all the K's. So these are all the K1s. Okay. And these two are using our range cutter equation for the Y and Z equations up here. Okay, is that cool?
Okay, since if the first I is 0, so wouldn't that be 1 in MATLAB? Is that why I goes from 1 to n?
Yeah. Yeah.
And if it goes to n, should it be n plus 1?
M plus 1. Where'd you get that from?
In the actual formulas, it goes up to n, right? The formula equation. So shouldn't MATLAB shouldn't be n plus 1?
Over here?
Yeah.
No. If you go n plus 1, you're exceeding the maximum boundary. N is the very last one. N plus 1, you'd go over. So n in this case is what, 3?
Oh, so if you put n in MATLAB, it already gives you the n plus 1.
Yeah. No. What do you mean it gives us n plus 1?
If you're going from 0, so isn't it removing one of the terms if you're doing from 1 to n instead of 0 to n?
No. It's because we've already initialized as well.
I think you're thinking of Python, right?
Yeah.
The Python's start and stop is like the stop is exclusive, but MATLAB's inclusive. I'm pretty sure. So n's the final one.
Yeah.
We're gonna go grab food from Matthews. Do you want anything?
Nah, so good. Thanks.
Right.
Okay, let me kind of make it a bit clearer. Does anyone want to take a photo of the code?
Yes.
Just give me a sec, Okay.
Will this code be uploaded?
I can upload it if you want. Okay, sure. Alright, if anyone wants to take a photo. That's the whole thing.
That's the whole thing.
Yeah, that's the whole thing. Yeah, that's literally your answer. And for normal range cutter questions, this one's a system of ODEs, right? So you're going to need 2k values for each one, but usually you only need 1. So it would be half the amount of code. Okay.
Oh, okay.
Cool. Anyone still taking photos? Oh, shit. What did you say?
I didn't take a photo of the board.
Oh, okay. We good, man.
I'm gonna keep sending photos of my feed.
That got caught on the mic. Hopefully. Okay.
Taking pictures of you.
Really?
Because you're so handsome when you code.
Thank you, bro. I appreciate it. Okay, okay, moving on. I'll quickly run the code. Okay, so we get values for y and z. So y and z, these are our values. So if I go to the Mobius, these are our y values down on this column. These are z values down in this column. True? Now the only problem is to find k. Right? I couldn't find an efficient way of finding the k values because every time I try, say k11, oh shit, k11, it comes up with one value. So the way you'd find k11 is probably just like individually substitute it in. So you'd probably do for f1 of x1, y1, z1. That gives us 0, which is this way over here. Okay?
Maybe you can put a break.
Put a break. Where? Over here?
No, like break at the end of just before the end.
Over here. What does a break do? No, it doesn't really work.
Can't you just like step through the for loop to like get all the different, like remove the semicolons at the end to display K1?
I've tried that, but they still give us just one value.
No, like if you step through it into like step through it line by line instead of, because like you're running the whole for loop, right?
Yeah.
But if you like step through it and do like one whole thing of it, it'll show you the k values before it like rewrites it to the k values. Does that make sense?
I'm sorry.
You have to get rid of the.
You just use the step function next to run.
Yeah, but you have to get rid of the semicolon so it'll like display it for you.
Okay, so I get rid of the semicolons.
Yeah.
What do you mean by step?
So see the step button next to the run button, like top right. No, right more. Yeah.
Oh, shoot.
And like you can just like spam it and step through the entire sheet basically.
How do I use
So
this?
you have to like keep clicking it.
Oh, okay, cool. Yeah, that does take a while though, I'll be honest. So it should show K11 over here,
Yeah.
K12 over here, so yep, works out. Then next one, yeah, K21, K22. Okay, yeah, that works as well. And it shows us the values over here. Okay, yeah, that works. I just did it individually, so stop. How do I get rid of this? So yeah, as I showed earlier, so x1, I'll do 2. What the hell? Oh, okay, that's why. It should be F2 or F1. No, sorry, K11. Sorry. Fuck me. Okay, I'm not sure. Is it because I've done?
I mean, you just cleared everything. So
Oh
I think
shit!
that's what-
Yeah, sorry.
Yeah.
Fuck. Yeah, I don't like this. No, wait, that's not right. It should be F1. There it is. Okay, cool. So this is the value for this one up here. K11 for Z2. So this one over here.
You could always create an empty array and then substitute it.
I'm not sure how to do that, I'll be honest.
If you go K11 equals to nan, and then that would go from 1 to n.
What does that mean?
So you just create an empty,
For n? Like that?
no, nan 1 to n. So you're creating basically a vector or a matrix that goes from 1 to n values.
Yeah.
And then inside your code under K11. Actually, name the nan one different, like K11 store. Yeah, and then under the K11 you go K11 I of K11 equal to K11 store I, and then that should store it. And then at the end of your code, like at the bottom, type K11 store. Maybe that one.
No. Oh, I think it's because it should be this. Fuck it, yeah, you just step through it. Or like what he said, just step through it.
Type K11 store at the bottom of the end, like after the end of your code.
Sorry, where?
No, keep that one.
Yeah.
And then after the end. No, keep that one. And then after the end, go K11 store. And then run it.
What have I done here?
Oh, I think it's because you're assigning K11I
Yeah.
to
shit,
K11
yeah.
store. I think it has to be the other way around, maybe.
Yes, that's true.
Oh, yeah.
This one? bro, I don't know. You can just do it individually, right? Hey, see, if you're in an exam and it's taking way too long, just do it individually. It'll probably be faster.
Explain the code that you did, like what it actually does.
Yeah, sure. Yeah, I did, but I'll go through it again. So good. Okay, so what do you need me to explain?
Just start to finish, like line by line, what you're doing.
Okay, so up here, I'm just writing up the equations. That's pretty simple, right? So then we gotta chuck in our initial values that we've got, which is straight from here. Sorry, from here.
Yeah.
Yeah, z of 0 and y of 0. Next, I'm gonna make an array for x. Okay. The other way you can do it is linspace 0 to 5, and then we're gonna have 3 subintervals. Or not 3-point values, right?
Yeah.
And then that'll look something like this: 0, 2.5, 5. Right? Okay. Then we're gonna make a for loop. Okay. We're gonna introduce our k values, which I've just copied straight from here. Yeah. So as you can see, this is f1, which stands for f1 up here. Yeah.
Okay.
And then we're substituting in our x values for each step.
X, Y, Z.
Yeah, x, y, and z for I. Right. So I've repeated that for all of them. And now we're going to use the Runge-Kutta method for y and z. Yeah. To find y I plus 1 and z plus 1. So over here. Right. Okay. And then once you do that, shit, wait, hold on, let me a bit neater. Okay, we're gonna type in, oh, we've already displayed y and z over here. These are our values. Okay. And so this one over here is y1, y2. Cool? So y1, y2. So for some reason he gives us an extra one, but I've tried to do this. Oh, there it is. Yeah. There it is.
So where's n? Just quickly.
N over here. So it's the length of our x array, which is
Which happens to be 3.
yeah,
Okay.
and we're iterating it twice to find our values. Okay. And then you can just do it individually. This is probably the longest part. Everything else is pretty easy.
So yeah, typing it into the thing.
Yeah.
Will take a while.
Yeah, typing in take a few minutes, and then finding all the k values will take like another few minutes. So since it's 25 marks, how long is the exam? 2 hours? This should take you like 30 minutes overall, maximum.
Is it four questions? Do you know?
I don't think it's 4 questions, but
Yeah, so-
by marks, because this is like 1/4 of the paper.
Right.
That's why.
But does that mean the numerics is probably going to be like that? Like there's going to be less questions in numerics to create values?
I didn't make the paper, bro. I don't know. I've got no freaking clue.
Yeah, so we're doing numerics and stats both in 2 hours. So numerics will probably be 2 questions, and stats is going to be 6 questions.
It could be 3-3.
Yeah. Okay.
Yeah. It's depending on the marks allocated. How long you spend the time. So you want to aim for like
So, what do you think should take longer?
which one?
Numerics or stats?
Stats.
Yeah.
Like numerics, you can just code all of it up and it pops out an answer, right? But then for stats, you're gonna have to actually understand the content. It's a bit cooked. So if it's like 25 marks, that's like a quarter of the paper. And since we have like 2 hours, it should take you like max 30 minutes.
Yeah.
The reason I'm saying max is because like if you exceed it, you're gonna be spending less time in your other questions. Right? So you want to like minimize the amount of time possible. Okay. Okay. I'm gonna move on to stats now. I'll come back to this question if I have time at the end. Because since it's at suitable, we're gonna have to actually like research a bit for that one, but I'm not too sure. Okay, so I'm gonna be going through the 2022 term 2 one. Okay. Okay. This is a pretty simple probability, yeah. So a weather reporter is interested in the weather on 3 consecutive days: Friday, Saturday, and Sunday. suppose the probability of it raining on Friday is 0.34. So probability of rain on Friday is equal to 0.34. How about if it doesn't rain on Friday?
166.
1 minus, which is 0.66, yep. Okay, so if it has rained on a particular day, the probability of it raining the next day is given by this, 0.74. So if you want to find the probability of it raining on Sunday, you're going to have to find the probability of it raining on Saturday, then multiply that by this. Cool? Okay, next. Furthermore, if it has not rained on a specific day, its probability of raining on the next day is 0.18. Yeah? Okay. Okay, so R1, R2, R3. So this is if it does rain on Friday, does rain on Saturday, and does rain on Sunday. Alright? Okay, what's the probability of it raining on Saturday? Okay. Any ideas? Ideas? Jad, any ideas?
Make a tree.
Make a tree. Yeah.
Probability tree.
It takes a while though.
Not really. So 4 branches.
I don't know. But it'll take a while. Yeah.
Rain on Saturday. So you do rain on Friday times rain on Saturday. Sweet.
Yeah?
Yeah, and then you do not rain on Friday times rain on Saturday.
Yeah, perfect.
Then you add those two.
Yeah, good. So you want to see if it rains on Friday and Saturday, right? And then if it doesn't rain on Friday, because there's 2 different cases for the Fridays. If it rains and if it doesn't rain. Okay? So this is using the notation, probability notation, right? So if it does rain on Friday, it would be 0.34. And if it rains the next day, as we said earlier, 0.74. Multiply them together. Okay? If it doesn't rain on Friday, that's 0.66. And then you multiply that by 0.18, which we've got from here. And your answer, you get 0.3704. Cool? Okay. Part B, what is the probability of raining on Friday given that it will rain on Saturday? So it's given, so, oh shit, that's the answer. Probability of it raining on Friday given that it rains on Saturday. So the formula that we're going to follow is R1, R2 divided by probability of R2. Okay, do we know what both of these are? Who said no? No one said no. Chad. Hey, do we know what this is? The probability that it rains on Friday and Saturday? We know that, right? Straight from here. So it's 0.34 times 0.74.
Is R1/R2 probability that it rains on Saturday knowing it rains on Friday?
No, it's the opposite. So probability that it rains on Friday given that it rains on Saturday. Okay?
So you put the Saturday one on the bottom.
So this one goes in the bottom. Okay?
A given B.
Yeah. So the formula that we're following is
And A or B is the same as B or A.
yeah. Hey, but do we know what the bottom is? How do we know what the bottom is? Part A. Perfect. Okay. The probability of raining on Saturday, we found it here. Okay. 0.374. 3704. So that is our answer right there. Okay. And you get that as your answer. Cool? You guys at the back? Moment? Yeah. Okay. Hey. Hey, the final part, that should say part C, by the way. Yeah.
Is that formula on the formula sheet?
Let me check. It should be in the formula sheet. Where is it? No, it's not.
Okay.
Yeah, no, it's a bit messed up. I think it's because it's part of the revision section, right? So it's like assumed knowledge. Okay. Last part. What is the probability that it rains on Saturday and Sunday? So Saturday and Sunday, we're trying to find. And yeah, that's and. By the way, this over here means and. This one means or. Okay, this is our intersection. And this is union. Cool. Sorry.
Wouldn't it be easier to sort of store R B or like write it the other way? That way you can divide by P of R2.
We don't need to. This is not conditional probability. Make sense? So we don't need to do what we did earlier. We don't need to divide by the probability of Sunday. Alright? So this is the formula that we're going to use. The probability that it rains on Saturday and Sunday. So we know what the probability is that it rains on Saturday, right?
Yeah.
We found it in part A. Probability that it rains on Saturday. And if it rains the next day, what do we multiply by? 0.74, right? Which is here. So if it rains on Saturday, 0.3704. If it rains on Sunday as well, we multiply by 0.74. Okay? Also, one more thing I want to note here. You have to multiply the probabilities for intersection, and then over here you want to add the probabilities. Yeah? Yeah? Okay, that's question 1. So, all good? You good? Okay. Can I move on?
Yeah.
Oh, shit, okay. Okay, so for this one, I actually found 2 variants online. There's this one, and for exponential distribution. And there's also uniform distribution. Okay. There might be more. I didn't really check. But those are the only 2 that I found. Okay, first of all,
Just a quick question. When you have probability of A union B, how do you know when you subtract or don't subtraction P of A into 17?
if they're not independent.
So if they're independent, it's P of A plus P of B.
Yeah. If they're not independent, you have to minus D. So you're going to have to use this formula. So yeah, how do you spell independent? Is that right?
Yeah.
Okay.
So for the problem we were doing just then, was it independent?
No. Yeah, they're dependent. Because the probability of something raining the next day is dependent on if it rained the day before, right?
It's P union of the beginning.
It doesn't really matter because chuck it to this side, chuck it to this side. Doesn't matter. So we can same shit, right? Okay. Okay. So so we have an independent exponential distribution, right? So they've given us what the mean is and what the variance is. Okay, that's also in the formula sheet. Right here. Yeah. Cool. Everyone see that? Okay. So what is the variance of the random variable? So we're trying to find this. Okay. Also, before I move on, a few key formulas that we're going to need. Okay. You might have recognized this from high school or 1A/1B. No, you don't recognize it? No? Oh shit. Okay, now you know.
Okay.
Hopefully you got that.
But they don't give it to us.
It's assumed knowledge.
Bro.
Well, if you pass 1A, you should probably know this. No? Yeah, I don't think they give it to us anyways. Well, you don't really need to worry, because... No, you do have to worry, fuck. Shit, sorry. It's over here.
Surely they give us the big ass one.
I can just do a bit of a memorization.
What's the big ass one? Are you talking about this one?
Like when you have. No, that's assumed knowledge.
I remember that one.
Yeah, it's assumed knowledge as well.
But
I do remember
there's
that.
when you have like variance of x and y.
Oh, the covariance one?
Yeah.
I don't see it, man.
They don't give it
I don't think they give it to you. No, they don't give it to you for some reason. Okay, I should probably learn that then. Okay. Okay, so moving on, if we're trying to find the variance of the square root of n x dash, this x dash, by the way, is just sample mean. Sample mean, and this one is a true mean. Okay? So what we're going to do, first of all, using this formula, take the square root n to the outside, and we have to square it. Yeah? That's straight from this formula over here. Cool? Make sense? And then all we have to do now is calculate the variance of the sample mean. Okay? So I've substituted this equation into here. Okay? And we see there's another 1 over n that we have to take to the outside. Okay? So we can square this and bring it to the outside. Cool? And then we can also actually take out the summation. Yeah, the sum. It's just the identity, you guys don't need to worry about it. Yeah, the proof of it. But just know that you can take it to the outside. Okay?
You don't have to square it.
No, you don't have to square it. No. Okay? So this one becomes 1 over n. And then when we're multiplying the sum of mu squared n times. So what this means is just we're adding it n times. So it will look something like this. So this is just equal to 1 over n times. Cool? Does everyone see this? Why I did that? Yeah? It's because of the sum. So we get our variance to just be mu squared. So it's actually exactly the same as up here, which is very cool. No, it's not cool. Okay? But yeah, we get this. Oh, 211. By the way, they've already given us mu. Yeah. So they've given us this. Okay.
So what does that actually mean? Does that mean the sample variance is equal to the actual variance?
The variance of this is equal to the true variance.
Yeah. Okay.
Yeah. I don't think that's a sample variance though. Sample variance probably has a different formula, but for this one, it's same as this. Okay. Okay. Now assume a sample size of 16. Okay. Determine the value of this probability. This one's a bit tricky. Okay. What I've done, I've let t equal to the sum of all the variables between 1 and 16. Yeah. And so if I simplify down, we're essentially just trying to find the probability of t being greater than 749. Right? Okay. People still copying them. I'll move on. And so the expected value of t, so expected value of this, right, is just the sum of the expected values. Where I get that from? Up here. That's where I get it from. Where a is just equal to 1 and b is just 0. Okay? So you can just sum them up and you get this. And do we know what the expected value of x is?
Not the mean.
It's a mean, which is what? Mu, which is 46. Good. So we can just say this is just 16 times mu, because there's 16 of them over here. So there's 16 times, and each of these is just mu. Okay, so we get this as our expected value of t. And I'll show you why I'm finding the expected value and the variance of t just in a bit, okay? This one, I didn't show the proof for this one. I'll quickly show you guys. Variance of x1 plus d. And this, each of these are mu squared. True? Does that make sense?
Yeah.
And then how many of them are there here? 16. Right, 16. So the variance, we just get it to be, the variance we just get it to be 16 times 46 squared. And then the standard deviation, this is the true standard deviation.
But the variance is mu squared.
Sorry? Variance is mu squared, yeah. They've told us here. And the reason for that is because it's an exponential distribution. If it was a different distribution, for example, uniform, then variance would be look a little different. Yeah. Okay. So now that we know all of these values, we can actually find the probability. Right? We're gonna make it into a standard normal distribution. Right? So over here, t minus the expected value. So if you guys, the z scores, you guys have the z scores. Okay, we're gonna use this formula, right? So this is just e of t, I've made it that, and this is just up here. Okay, so we're trying to find the probability of z being greater than 13 over 184, which you can use MATLAB for. And you get your answer to be 4718. Have I lost anyone? No? Did I go too fast? You guys at the back, good?
I have a question. Isn't this exponential?
Yeah.
Can you get normal CF?
That is true. However, if you scroll down a little, exponential.
Isn't there an x CDF?
Do you
Did
get
you get the right answer with no CDF?
Yeah.
Can you try it with?
Yeah, sure. I'll quickly try it. Oh, I actually don't know why that worked. What was it? 13.
On 180.
No, it's 949. It's 46. No, it doesn't work. Oh, sorry, XPDF. Because you were trying to find the probability. No, that still shouldn't work. Yeah, no. Wait, let me quickly figure
That's
out.
XP.
Oh, sorry, it doesn't follow a distribution of exponential. It doesn't follow exponential distribution. It's just that the variables are independent.
Isn't exponential a form of normal?
Yes, it
That's
is.
why no CDF works. Because normal is like a general. And then exponential specific.
Okay, I think the reason why it works is because we've made it into, we've standardized it, if that makes sense. We've used a z value to make it into a standard normal distribution. So you can have like different distributions. You can have like exponential, uniform, normal, bino. But if you want to standardize it all into one, so even though norm CDF works, we're going to have to use a z-score. Z-score, and then you can just use norm CDF.
Can you just follow that thing?
What?
I understand it.
No.
Thanks.
Oh yeah, there you go. Is that good?
Yeah.
Yeah, no, that's a bit of a tricky question, I'll be honest. I'm not too sure myself. I am doing the course with you guys to work. We'll see. Alright, the next variant I want. Do we have time for the next variant? Oh, 13? Oh, yeah, sure. You're talking about this one over here? So 13. So I'll quickly show you. What's up? Give me 1 sec. Let me quickly show them. Minus, what's E of t? 736. Dividing that by 184. Do it in calculator, you get the same answer, right? So 13 over 184, 0.707. Hey, what do you need a photo of, brother? This?
Just the normal CDF one.
Sure. No worries. Hey, can I move on? Alright. The next variant is with independent uniform distribution. Variable, sorry. So these formulas are actually on the formula sheet as well. Apparently not. Oh, it's right here, sorry. Okay, so it doesn't match. Variance, I don't have it here. Yeah, it's the same formula. Okay. So, to find the variance, it's the same steps essentially, except the variance changes. Before, the variance over here was mu squared, right? But in this case, it's 1 over 12 beta minus alpha all squared. Cool? So they've given us that beta is equal to 18, I think. 18, and alpha is equal to 3. So in here, we get 15 squared. Right? And you sub into your calculator, you get 1 over 12 times 15 squared, 75 over 4. Okay? Cool? Right, I think people are taking a photo. Can we move on? Alright, next. So again, I'm going to let t be this, the sum of the random variables. We can find the expected value and the variance. In this case, mu. Mu will equal to alpha plus beta over 2, which is just 21 over 2. And this is why we get 210. Right? The variance, I'm going to use the formula from earlier. And then now, we're following the same steps. Because we've standardized it using the z-score, yeah, we're allowed to use norm CDF. Alright? Cool. Let me get this as the answer. I quickly want to go over one more question before we end.
You know the weekly 10?
This one?
Yep.
I haven't done it now. So, oh yeah, I'll quickly go through this one question. So now this one is like the hypothesis tests from like week 7, 8, 9, right? So a particular computer chip manufactured by company Delta, reported to last 8 years without failing. So our sample that they've given us, so is equal to 14 over 154. Everyone see that? 14 over 154, all right? Because it's last 8 years. All right, test statistic for a sample uses a different formula, okay? So I'll quickly go back down here. Oh shit, wrong one. We have to use this formula over here for the test statistics for our sample, right? I can upload those notes later on, by the way, if you guys want. So test statistic is given by this. This is 14 over 154, was it? The pi value, they've given it to be this, 0.09, okay? Now, all we need to, oh, actually, we also have to find n. What do you guys think n is? Our sample size.
154.
154. Okay. Now, substituting this in, all over here, this equation, we get our test statistic to be 0.0394. Okay? So plug all of these into the formula up here. So I'm writing down. Give me a sec. There's also a few other formulas. So I'll say this one is for samples. So this is if we test statistic for the true mean, but we know what the standard deviation is. If we don't know the standard deviation, however, we're going to have to use a sample standard deviation, S. Right? So that's usually when they give us a set of data, like in question number 5, I believe. Yeah, so when they give us a set of data like this, you're going to have to find S using the standard deviation function on MATLAB. Okay? So I'll go back to question 3, was it? 3, yeah. Okay, now to find the p-value, which is one thing to note, however, these test statistics, they follow different distributions. So if we know what standard deviation is, it follows the normal distribution. If we don't know it, it follows the t distribution with n-1 degrees of freedom, right? If we doing it for samples, it follows the normal distribution as well. So in this case, we use norm CDF. How about for this one? TCDF, yeah. / tinv, right? Okay, so I've used norm CDF of our test statistic, and we get a p-value of this. Okay. One thing I want to ask though, does this provide evidence against H0?
No.
No, it's too big, right? So if it's like less than 0.001, oh no, 0.01-ish, approximately, then you would have evidence against H0. But because it's like way too massive, yeah, it doesn't provide evidence. So it might be 0.05, I'm not sure. But essentially, smaller p-value provides more evidence. Against, but bigger the p-value doesn't provide much evidence at all, right? Cool? Yeah? Okay, part B, this one over here. So for part A, we've used the central limit theorem, right? So we've used CLT for part A to like approximate our p-value, right? But we can also find it exactly, right? Does anyone, oh, they've already told us, you might want to consider a normal distribution. Why is that the case? Why is a normal distribution? Why not exponential or normal? Read the question real quick. Why is it binomial?
Yeah,
Yeah, it's either probability of failure or success. So there's only two outcomes, failure or success. That's why we have to follow a binomial distribution. Okay? So, this is the code, oh sorry, this is not the code. This is the code on MATLAB to find the probability. Exactly. So you guys can see it's a bit different, the p-values. Yeah? Does this provide more or less evidence? More or less? Less, right? Because it's a higher p-value, right? So you can do this by hand. It will take probably like 3 hours to get it. So you wanna use MATLAB to find it, okay? Okay. Part C, we're trying to find the sample size for a confidence of 99%. Okay. They've also given us a value of error or margin of error. Margin of error 0.02. Right. So scrolling down, for a sample, this is the formula that we have to use. I don't know if they've given it to us in the formula sheet. Sample proportion. Oh, see, you guys can see over here, this follows the t distribution, normal distribution, and normal distribution. They have not given us the formula. Okay, that's alright. You're just gonna have to memorize it. Right? Where it comes from is that E is equal to Z1 minus alpha on 2.
You can rearrange the Z formula given and you can find the n.
This one?
Yeah.
Yeah, right? So I think this is from the lecture slides, and then I've rearranged it to get this. Okay? Okay, because we have a confidence of 99%, the 1 minus alpha on 2 value will be 0.995. Yeah, and why is it norm-inv and not t-inv? Yeah, essentially, it follows the normal distribution. Right, and it's a binomial, that's why. Okay. P-hat value we found earlier, this is given to us. Substitute it all into the equation up here, and you get an integer or a value of 1371. Cool?
Is there a binomial in?
There is? No, I don't think so. Is that a binomial CDF? Let me check.
There is.
Yeah, binomial CDF.
Yeah, this is binomial CDF. I don't know binomial inv. It does exist, yeah. Alright, I've got one more question to go through. Very final question. Okay, so just going up. The good thing about this is that they've given us this equation. It's also in the formula sheet, I think. This one over here. But instead of SP, they've given us the sample proportion. Yeah? So instead of this, they've given us this. Okay. Oh wait, is it the same formula? It's very similar, okay? They've given us what P hat is, P1 hat, and P2 hat. We just have to find these individually and substitute it all into the equation. One thing I want to note though, what's pi 1 and pi 2? Well, actually, what is the value of this whole thing? E? 0. Yeah, perfect. Because we're trying to prove for pi 1 is equal to pi 2. And if they're equal to each other, this just cancels out. Right? P1, calculate using this. P2, using this. The overall P hat, using this formula over here. And then N1, N2 is what we already know. Right? So they've actually introduced phi. And this is the sample proportion for it. 14 over 172. Okay? So what I've done, I've substituted all these values in here. We get a test statistic of 0.3061. Okay? And the p-value that they're trying to find is for greater than, p1 is greater than p2. So we're trying to essentially find that p is z, or probability of z being greater than 0.3061, which is given by this on MATLAB. Okay? So our final answer we get to be this. I think it's the same answer. Yeah, it is. Check it real quick.
Is the p value always bigger than the test statistic?
Oh, not necessarily.
It depends on the problem.
Yeah, it depends on the probability. The problem. Yeah. Okay. I think that's it from me for today because we've got like 4 more minutes. I can't go over a question in 4 minutes. So. Yeah, we'll just end up.
Again, you can help yourself some snacks, drinks, feel free to stay in the room. But in the case that we have an influx of people due to concrete, we'll have to kick people out for like, yeah. Surely that won't happen, but yeah. Good luck with your exams.
I'll upload the notes as well. I'll upload the notes into the chat.
Yeah. Oh, sounds good.
Okay.
Well, where can we find this like a document like the notes from you?
These notes over here.